Alright, everybody, I apologize for the craziness of today, but I appreciate your patience with the situation. I'll be introducing the next lecture, which is comparing two sample means. This is the next step in moving towards doing another version of a t-test. So in our last couple of lectures, we were working on t-tests where we were comparing from a national average to from our mean, a sample mean, to a national average. Now we're going to compare between two sample means. So starting off with just generally, t-tests are procedures that allow for comparisons between two sample means. What we spent the last lecture doing doesn't happen very often. Like we talked about, there aren't usually a whole lot of instances where we can compare a sample mean to a population parameter. So typically when you see a t-test, it's a procedure between two sample means. Many practitioners believe that only one form of t-test exists. However, this is not really the case. Actually, t-tests consist of a variety of different designs. So we're going to talk about a couple of them. For this first homework assignment, you're going to have to do two of them. So t-tests vary on two different aspects. The first aspect is the level of measurement of the dependent variable, and the second is the type of the independent variable. So you want to really make sure you have those 2 points down. The level of measurement of the dependent variable and the type of the independent variable. Once you know those two things, when you combine those two elements, we can create 4 different potential t-test procedures, and that's what we're going to be introducing throughout this semester. We're going to introduce the first one in this lecture, the second one in the following lecture, and the last two later in the semester. So the level of measurement of the dependent variable is one of the elements. You can either have a parametric test, which is an interval or ratio level of measurement. And like we talked about, often interval or ratio levels of measurement are combined in statistics, so it doesn't matter if you're doing kilograms and you have a meaningful zero, or if you're doing a sum or average Likert scale and you don't have a meaningful zero. As long as you have that standardized scale, you can feel confident that doing parametric is appropriate. The non-parametric tests, we're going to do a lecture on non-parametric at the end of the semester. Non-parametric is when you have ordinal levels of measurement, and therefore we're not going to approach those really until very late in the semester. So big general things that we see, parametric versus non-parametric. Parametric, you have a normal distribution of dependent variable scores. So that's where we would expect if we looked at the skewness of our dependent variable. It would be a normal distribution. We'd have a sample size greater than 30. We have dependent variables that are at least interval level of measurement. And that sample size greater than 30, that's really coming from the central limit theorem. Non-parametric statistics often have fewer assumptions. As a consequence, they have to be a little bit more conservative. The t-critical values often move up and get higher in order to make it harder for us to reject the null hypothesis. So when we have a non-parametric statistic, normality is not usually assumed, so that means you could have a skewed distribution. Large sample size are not required, so you could have smaller samples of n equals 10, n equals 20, and you could have variables that are dependent variable that are not interval level of measurement. So in a t-test, what that means is that an ordinal level of measurement is commonly used. So when we break those two elements apart, the level of measurement of the dependent variable and the type of independent variable, we have four different potential. We have our parametric statistics and we have our non-parametric statistics. Like I said, for this part of the class, we're really only going to focus on the parametric statistics. So next we're going to break down the independent groups versus repeated measures, and this is referring to the type of independent variable.